So we'd like to determine the convergence of this series. This is an infinite series. We can go ahead and start it at 0 or 1. And first thing we should notice about this is we have basically a rational expression here for our sequence. So let's observe what's going on with the lead terms. Now, we can tell that this is going to go to 0 as k goes to infinity because we have a much larger power on the denominator than the numerator. So that checks out. So now we need to think about how to test this. And the easiest way is going to be to use a limit comparison test, and let's see how we're going to do that. So we're looking at the limit as k goes to infinity, and one of the two needs to be our given sequence. So k cubed minus 2k squared plus 1 all over k to the 6 plus 4. Now, we get to pick what we're going to compare it to, and again, we'll go right off of the lead coefficients. Let's compare it to k cubed over k to the 6th, but actually we can reduce that because k cubed over k to the 6th is just 1 over k cubed. And we know that that series is convergent. So we're just going to compare to 1 over k cubed. And notice we don't do the series, we just do the sequence piece. So this is going to flip and multiply because we're doing division by a fraction. And we're going to end up with, this is going to be multiplied by k cubed over 1, which gets rid of that. And it'll distribute, so we'll have the limit as k goes to infinity of, we're going to distribute that term to all of these, so that'll be the most important one, but we'll do the whole thing. K to the 6th minus 2k to the 5th plus k cubed all over, and then we don't change anything in the denominator, k to the 6th plus 4. We know from our study of rational functions that their end behavior is dominated by the lead term of the numerator and the denominator. So we could use L'Hopital's rule, but we know that this thing is going to go to k to the 6 over k to the 6, which is 1. So we know that this is going to be equal to 1, which is a non-zero finite number. So we get that our series is convergent because we compared it to because the series 1 over k cubed is convergent by p series, and we also used the limit comparison test. So we compared via limit our series to one we knew to be convergent once we used the limit comparison test.